Overheating wires on the load side of a variable frequency drive, or VFD, can indicate a number of underlying issues. It is important to systematically investigate potential causes to prevent further damage and ensure safe operation. Firstly, examine the connections. Even if they appear tight, loose or corroded connections can create significant resistance, leading to heat generation. The increased resistance restricts current flow, resulting in localized heating at the connection point. Carefully inspect all connections on the load side of the VFD, including those at the VFD output terminals and the motor input terminals. Ensure that the connections are clean and free of corrosion. Use a wire brush or appropriate cleaning solution to remove any oxidation. When reassembling the connections, apply an antioxidant joint compound to the conductor surfaces to prevent future corrosion. Tighten the connections to the manufacturer's specified torque. Secondly, consider the wire size and insulation. The 3/0 copper THHN wires may be inadequate for the high current demands of the VFD and motor, especially during acceleration or peak load conditions. Undersized wires will exhibit excessive voltage drop and heat up due to increased current density. Furthermore, the insulation may not be rated for the temperatures it is being exposed to. Verify that the wire size is adequate for the motor's full load amps, taking into account any dirting factors for ambient temperature or conduit fill. Consult the National Electrical Code, NEC Table 310.15, for allowable ampacities of conductors. Check that the insulation type is suitable for the operating environment and temperature ratings. If the wires are undersized, replace them with properly sized conductors that meet or exceed the NEC requirements. If the insulation is not rated for the application, replace it with higher temperature rated insulation. Thirdly, investigate the possibility of a short circuit in the motor or VFD. A fault within the motor windings or VFD components can cause excessive current flow, resulting in rapid overheating of the wires. Perform insulation resistance tests on the motor windings using a megometer to check for shorts to ground or shorts between windings. Also, check the VFD components such as the insulated gate bipolar transistors or IGBTs and capacitors for any signs of damage or failure. If a short circuit is detected, repair or replace the faulty component. Fourthly, assess whether the motor is being overdriven. If the motor is overloaded or driven beyond its rated capacity, it will draw more current than it is designed for, leading to overheating of the wires. Verify that the motor load is within the specified limits and that the motor is not being subjected to excessive torque or speed demands. Check the motor's nameplate data for its rated horsepower, voltage, amperage, and speed. Compare these values to the actual operating conditions to determine if the motor is being overloaded. If necessary, reduce the motor load or increase the motor size to prevent overloading. Fifthly, examine the VFD for any malfunctions. A faulty VFD can send excessive voltage or current to the motor, resulting in overheating. Check the VFD settings and parameters to ensure they are properly configured for the motor and application. Also, monitor the VFD input and output voltages and currents to check for any abnormalities. If a malfunction is suspected, consult with the VFD manufacturer for troubleshooting and repair assistance. Consider additional factors. Check the temperature ratings of the insulation on the load side wires to ensure they are suitable for the operating conditions. High ambient temperatures can exacerbate the problem of overheating wires. Use a thermal camera to identify any hot spots in the VFD or wiring. This can help pinpoint the source of the overheating and identify potential problems. Check the torque and speed settings of the motor to ensure they are appropriate for the application. Incorrect settings can cause the motor to draw excessive current. Consider installing a current limiting device such as a fuse or circuit breaker to prevent overloads and protect the wiring. Recommended actions include the following. 1. Replace the damaged wires with properly sized and insulated conductors. Ensure that the new wires meet or exceed the NEC requirements for the application. 2. Tighten all connections properly and use antioxidant grease to prevent corrosion. This will help ensure a good electrical connection and prevent future problems. 3. Check the motor and VFD for any faults or malfunctions. Repair or replace any faulty components as needed. 4. Monitor the current draw and temperature of the wires and components to ensure they are within normal limits. This can help identify potential problems early on and prevent further damage. 5. Consult with the VFD and motor manufacturers for additional guidance and support. They can provide valuable insights and assistance in troubleshooting and resolving the issue. Remember that the information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or engineer before performing any electrical work. In this specific situation, the fact that Phase 2 was significantly worse than Phase 3 suggests an imbalance in the current distribution, potentially due to a failing component within the VFD that disproportionately affects that phase. While the connections seem tight, it's important to remember that even a slightly loose connection can cause significant heat buildup over time. The distortion of the copper wire and brittle insulation on phases 2 and 3 are clear indicators of prolonged exposure to excessive heat. The fact that the amp draw was equal and less than 90 amps after the repair might indicate that the initial issue was exacerbated by the damaged wiring itself. The damaged wiring would have created increased resistance, leading to more heat, further damaging the wiring, and so on in a feedback loop. The 200 amp fuses protecting a 400 amp breaker feeding the VFD might seem unusual. The fuses are likely sized to protect the wiring feeding the VFD, while the 400 amp breaker protects the overall panel. Always ensure that all protective devices are properly sized for the conductors and equipment they are protecting.